Section 2.5 and 2.6 deal with a real-world situation. I'm sure that many of you have gone to a store and have tried to purchase a product and have tried to decide which brand you should buy, or if you should buy the large volume or the small volume. Which is the best buy? Some of you will walk all over a mall trying to find the best price of things, and so you learn how to compare things and determine whether or not a particular purchase is what you want to follow up with, which is the best buy for the least amount of money. And so we're going to talk about that here. As you see, this is entitled U.S. Shirts. We're going to be using tables and graphs and equations in finding out the price of some shirts, t-shirts basically, and which company gives me the best deal. So this whole next couple of sections is going to be dealing with that, and hopefully you'll be able to relate to it because of the things that we do every day, and that is shop. So here's the situation. You're going to work at a t-shirt shop called U.S. Shirts, and we're going to use U.S. Shirts not only in this section but in section 2.6 as well. And so you work at this place and you have people come in and they order t-shirts from you, and they want to have a tie-dye, or they want to have a logo put on their shirt, or maybe a family reunion or something like that. And so you say, yes, we can do that. What we'll do is we'll charge you a certain amount for each shirt, in this case $8. But what we're going to do is, for this one-time setup fee to get the silk screen and everything done, we're going to charge you $15 one time. So $8 per shirt plus $15 to set it up. So I've already answered to some extent number one for you. Describe the problem, situation, and your responsibility in your own words. We have this happen nearly every year with either the cheerleaders in the school or with the officers. The officers generally buy their jackets from Coleman Knitting, but we also then go and get a t-shirt and sometimes a polo shirt that will have a logo on it. And there's a fee for creating that logo and setting it up, and then that's added to each of the t-shirts at a one-time basis. So you go in this case you pay your $15, and then each shirt after that is $8. So down here in problem number 2, what's going to be the cost of $3, or 3 shirts, of 3 shirts? So you're going to multiply 3 times 8, and don't forget the setup fee, and figure out what that is. Part B, 10 times 3, or 10 times 8, and then add 15. C, 100 times 8, and then add 15. And then down here explain how you calculated each total cost. Well, you can see very easily that this is a multiplication problem and then an addition. And then problem number 4A, this is a little bit backwards. I only have $50 to spend, so how many shirts can I purchase? Well, you're going to have to subtract the $15 from the 50, and then divide it by the cost of each shirt. So there's the equation for you to deal with, and you should be able to get 4A correct. These next ones then just go through. Now I've only got $60 to spend. I got $220 to spend. Make certain that if the number is 4.725, remember that you can only purchase 4 shirts. Pretty tough to buy 0.75 part of a shirt. And then number 5, explain how you calculate those numbers. Number 6 is to go back and get the information from the previous page, complete the table. I'll give you a hint. The first one is the number of shirts ordered is 3, and the total cost, I think you've got that from a past one in the previous pages. So you should be able to fill this chart out and figure out the total cost in the dollars. So this is very little math right here. All we want to do now is have you define something. What are the variables and what they represent? Number 8, what are the constant quantities? Number 9, which variable quantity depends on the other variable quantity, so which is independent and which is dependent. And then number 10, which of the variables from question 7 is the independent variable and which is dependent. So no math on this page, just answer the question. Okay, this number 11 is a little bit tricky, so I want to spend some time here discussing it with you. There's some terms in here that we haven't used before. The term lower bound and upper bound and interval. And these answers, the lower bound and the upper bound, have to do with the graph here. Now this is going to be difficult for me to draw because it's so small, but you should be able to do this on your paper. This point right here is point 0. Okay? We know that this is the x-axis, and we know that this is the y-axis. Well, the lower bound of both the x and the y-axis, in other words, the smallest number that I can put in here for the x and the y-axis is 0 and 0. I'll give you that little hint right there. When you haven't produced any shirts, you don't have any cost. But then what's going to happen is that you're going to start to sell shirts. And the question is, what is the upper bound of the x-axis? Now, we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be a way to do the lower bound of the x-axis. I'm sorry, the upper bound of the x-axis. But that won't let our numbers fit. If we go back to the other pages, you'll notice that checking off 1, 2, 3, 4, 5 on the x-axis and 1, 2, 3, 4, 5 on the y-axis doesn't work. And so we've got to change what we do here. We're going to have to set an upper bound. What is a large number that I can put right there? What's that largest number? And what's the interval that I'm going to put in the x-axis? The interval could be 1, 2, 3, 4, 5. We know that that won't work. 2, 4, 6, 8, 10. That doesn't work. We could do all sorts of things. The one that does work is 10. So if you mark each one of those on the x-axis as 10, you'll find out what the upper bound is by just counting. Now let's take a look at the y-axis. The y-axis, we're going to be spending a lot of money for a lot of shirts. How many shirts we're going to be selling, I believe, is 150. So that may give you some idea as to what the upper bound of the x-axis is. And you get that 150 from the previous pages. Now remember, I've told you many times, this book does this often, where it will get information from another page or 2 or 3 pages previous to fill out tables on this particular page. Well, the more t-shirts we sell, the more the total cost. And so this upper bound is going to have to be a pretty large number. And the increment is going to have to be a pretty big interval. And when I say interval, again I'm saying 1, 2, 3, 4, 5 or 2, 4, 6, 8, 10. Those are the intervals. So this is going to have to be a fairly large interval. I would like you to take a look at it and count with your group and see what the interval should be for the x-axis and the y-axis. I'll tell you that the interval for the y-axis is much larger than the interval for the x-axis. And then you're going to be graphing some ordered pairs. Well, the ordered pairs are given to you on the chart on the previous page. And then, again, answer 13 and 14. Do all the points on the line make sense, and define the variables and write this algebraic expression. Now, we've had examples of writing the algebraic expression. We did that a lot in Chapter 1, where we had we were trying to do a car wash. Do you remember? And we had a situation where one of the things was unknown, and then we did an x plus 750 or 2 times x minus 10, whatever the equation was, and we created equations out of that and was able to determine how big x was. So this algebraic expression, however, will not look quite like that. this algebraic expression is going to look like this. Y equals mx plus b. On this page, I just want you to finish number 15, but we will not do talk the talk. So now we're going to talk about another t-shirt company called Hot Shirts, and we're going to be comparing what we did in 2.5 with some things in 2.6. We're going to do some estimating here. We haven't done that before. And we're going to talk about the point of intersection. A lot of times what happens when you go shopping is that you'll see two different products that give you different scenarios. In other words, one may say that they're going to charge a $15 setup fee, but their shirts cost a little bit less, or another one says, I'm not going to charge you the setup fee, but our shirts cost a little bit more. At what point in time do you either break even, or does one become more expensive than the other? And where they break even, that will be the point of intersection. And then you can determine from there how many shirts you need to purchase as to which is really going to be the best buy. So here's a chance for you to do something real world. If you're ever in a position where you're going to buy multiples of things and you've got two different companies wanting your business, it's a good thing for you to analyze and to scrutinize and to put down on paper and pencil what really is going to be the best deal for me. This has nothing to do with whether the fabric is better or worse or anything. We're not worried about that. It's just a t-shirt, and we're going to compare these two companies. So here, starting with problem number 1, you're going to answer the same kinds of questions that you answered earlier in 2.6. 3 shirts, 10 shirts, 50, and 100. But you'll notice that the numbers this time are going to be different. This time there's a one-time setup fee of $49.95, but the t-shirts only cost $5.50 each. So they're a little bit cheaper, but a bigger expense right here to set them up. So rather than just take this thing on face value, and you say, oh, well, $49.95 seems like an awful lot of a much bigger setup than $15. I'm going to go with the other shirt company, U.S. Shirts, I believe it is. You might want to take a better look at that, depending upon how many you want to purchase. If you're only purchasing one, you need to take a look. If you're purchasing 100, different kind of view. If you're purchasing 1,000, even a different kind of view, which is going to be the best buy for you. So here we're talking about estimating. To estimate means to understand how to round things up or down. So if I were to take a look at this problem right here, 748.75. If I were to estimate and round that up, or round that off, I would round it to 749. And the reason being is that 75 is closer to being a whole number than not. Now the 60, 22. The 0.22 is not close, or even half, and so this would be rounded off to 60. So the estimate is 749 plus 60. And it's not a bad way to do things. Estimating makes life a lot easier. The key is this number right here. If that number is bigger than 5, is 5 or bigger, I should say, you will always round up. If it's less than 5, you just drop it off. So 748.7, that 0.7 is bigger than 5, so it rounds to 749. 60.2, that 2 is less than 5, so you just drop it off and leave it at 60. So do some estimating. Then number 5, estimate the number of shirts that a customer can purchase from Hot Shirts for $50. And these are going to be somewhat guesses. Estimating is a guess. You should be able to come pretty close, but the answers will vary. Here's a table just like the one we've already filled out before. I think we've done this twice. We'll now just use it for this particular scenario with the shirt company that we're dealing with. The numbers will be slightly different. You'll see, but you're going to see how they're going to come together in a minute. Here we go again with the lower and the upper bound. Again, the hint, that is 0. And what's the interval going to be here? What's that highest number there? And what's the highest number there? The increments or the intervals will be slightly different, and see what numbers need to go there. And now we get into the idea of which is the better buy. So the numbers that you've been using for section 2.6 and 2.5 and 2.6 now come into play. You'll be turning the pages back and forth. You'll be looking at the various graphs. You'll be looking at the ordered pairs that are sitting there. You'll determine what the cost is for 5 shirts for both companies, what the cost is for 18 shirts, and see what happens on the graph and see how close they start to get, and then which t-shirt company is the best to buy from if you're buying a small amount or if you're buying a large amount. So here is the table already filled out for you. I hope that this matches with what you put in the other 2 previous tables for the upper and lower bound. The lower bound for both is 0, 0. The upper bound for the X is 150, and I'm going to put that in right here. So here's 150, not a very good 5. And for the Y, it's 1500. The interval along here is 10, so it goes 10, 20, 30, 40, 50, up to 150. And the interval up the Y-axis goes 100, 200, 300, 400, 500, up to 1500. So now you get to take a look at both the charts, or all of the charts and all the tables and all the information that you've been gathering, and estimate the number of shirts for which the total costs are the same, and how many shirts for how many t-shirts is more expensive to order from U.S. Shirts, for how many t-shirts is it more expensive to order from Hot Shirts. Look at the graph and describe what's happening, and then you will see right here, and this is an estimate, but at about 14 and 127, that is the point of intersection. So that tells you that when U.S. Shirts sells 14 shirts, the total cost is 127, and when Hot Shirt sells 14 shirts, the total cost is also $127. So at what response do you give your boss? Remember, you're out trying to find out how the competition is going to affect you, and you're finding out that at 14, both of you have the same price. Which one then, over a large number of shirts, is going to be the least expensive, and over a large number of shirts is going to be the most expensive? Section 2.7. We are now going to be dealing with graphs that are not linear equations. One of the graphs that we're going to be dealing with is called an absolute value function. Another graph is called the square or quadratic function. We will refer to it as quadratic. And the other one is a cube or cubic function. These 3 graphs are what we're going to be looking at. They will not form straight lines. You'll get a chance to create some curves and create some V's and create some U's, and so there's a whole different ballgame here in relationship to creating these graphs. This is an example of an absolute value graph. Remember that the absolute value of a number is always positive. The absolute value of -3 is 3. The absolute value of 11 is 11. The absolute value of -5 2/3 is 5 2/3. And I would honestly change that number. I would make it 17/3. And the absolute value of 110.89 is a positive 110.89. So now we're going to create this table. You're going to have y equals the absolute value of -7. The absolute value of -7 is 7. So y is equal to 7. So that's what's going to go here. Here's my x, and here's my y. So the same thing applies with that -3, and that -1, and that -0.5. The absolute value of 0 is 0. y equals the absolute value of 2 is y equals 2. And you're going to find something here when you graph this thing. You will start with a straight line, and then it's going to go to a point, and then it's going to go back up. And so you're going to form a V with this particular graph. Thus, right up here it says the V. You need to learn to recognize this family of functions. When you deal with an absolute value, the graph is always a V. So here's what's going to happen on the test. On the test, they're going to give you an equation and have you match that equation with a graph. Or they're going to give you the graph and have you match that graph to the equation. And we'll do enough of these that you should be able to recognize it. This is something for you to study and memorize. If you'll do that, this is easy. But if you just blow it off, then you're going to have some real difficulty remembering which graphs goes with which equations, and vice versa. Nothing to say here, just go ahead and graph this thing. Okay, so now what we have here is a graph called not a V, but a U. And so we've got some terms here in my x, and we see now that the equation is y equals x squared. So if I go y equals a negative 3 squared, y equals 9. Because the negative 3 times the negative 3 is 9. What's going to happen now is that you're going to fill this whole thing out. We'll go down to the bottom one. Y equals 3 squared, so y equals 9. And you'll see that it's going to go down and go back up, but it's going to create what is known as a smooth curve. It won't be a V, it'll be a smooth curve. It will be either a U or it'll be an upside down U, depending upon some attributes of the equation. I'll tell you that this particular equation right now forms a U that opens up. And so here it is, answering the questions and just graphing it. And I didn't do this on the last one, I'm sorry. This is known as a quadratic function. Okay? And the quadratic equation, we won't go into it. It looks like this. You can see it right there at the bottom. ax squared plus bx plus c, and I'm going to change it a little bit, equals 0. And there's a huge, huge mathematical operation that can take place that changes this thing into what is known as the real quadratic equation. And that one looks like this. A minus b plus or minus the square root of 4ac. Oh, that's not right. That's not right. I need to erase that. It is minus b plus or minus the square root of b squared minus 4ac all over 2a. And I need to erase this again and put it in better. So minus b plus or minus the square root of b squared minus 4ac all over 2a. There, that shows how smart I am, even though I got it wrong to begin with. We won't deal with this. I just thought I'd put it on there just for fun. Okay, so now this is neither a V or a U. This is kind of an interesting little curve that is made. This is known as a cubic graph, and so we're going to go y equals 2 cubed. Now, let's not get this confused. This is not 2 times 3. This is 2 times 2 is 4, times 2 is 8. Oh, it's a negative, so it's a negative 8. So a negative 2 times a negative 2 is 4, and 4 times a negative 2 is a negative 8. So a negative 8 goes right here, and then fill out the rest of it. You can do this on your calculator very easily. There is not a cubed button if I remember correctly, but you can just go negative 2x or times negative 2 times negative 2, enter. Negative 1.5 times negative 1.5 times negative 1.5, enter. Remember to choose the negative button on your calculator, the one that's on the lower right, not the minus sign that's listed with the plus, minus, divide, and multiply keys. This is the minus sign that's down on the lower right. It's got parentheses around the little negative sign to indicate that it's negative. When you graph this thing, it's going to look something like this. That is the cubed graph, and I'm just going to draw an XY axis in here somewhere because I'm not really sure where it's going to end up. Sometimes it goes to the origin, sometimes it does not, but it was going to look something like that. On this one, I want you to do the talk. I want you to explain what the graph looks like when y equals the absolute value of x, what the graph looks like when y equals x squared, and what the graph looks like when y equals x cubed. You need to recognize these families. You will use this a lot, especially next year in the Secondary 1 course, where you really start to zero in on the function families. That finishes the chapter, and then just before we take the test, we will go through the chapter summary, and we will review this for you and get you ready to take the test. Again, very similar stuff to what we've had in the first chapter. We've added a few things to it, a few fun graphs, recognizing the function families that are linear, that are quadratic, and that are cubic.